On this video, I'm going to show you how to solve the ALEKS problem called Predicting the Qualitative Acid-Base Properties of Salts. This problem is actually really tricky, so you're going to want to take your time while you're working on this. Go slowly and make sure you don't make any mistakes. So for this problem, you're going to be given 4 solutions. Notice that they all have the exact similarity, and you're being asked to rank these solutions in order of increasing pH. You're not going to be asked to calculate the pH of these solutions. You're just going to be ranking them. So, you're going to put a 1 next to the solution that has the lowest pH, the most acidic. Up here, you're given some Kb values and Ka values for some molecules, but unfortunately not for any of these molecules that are down here in the actual problem. So you're going to have to kind of take this information and make it work for the molecules that we're actually working with. This problem is essentially asking us to rank not acids and not bases, but ionic compounds that have acidic properties or basic properties. So the first thing that I want to do is just kind of go over, for an ionic compound, what makes it acidic, what makes it basic. Ionic compounds have 2 components. They have a cation and an anion, the positively charged ion and the negatively charged ion. Cations in a molecule are always either going to be neutral or they are going to be acidic. Cations can't be basic, and the neutral cations are the ones that come from groups 1A or 2A on the periodic table. So that's how you'll identify them, is just by looking at where they're located. All of the other cations are acidic. The anions in an ionic compound are going to either be neutral or they are going to be basic. And our neutral anions are chloride, bromide, iodide, perchlorate, ClO4-, and nitrate, NO3-. And the basic anions are all of the other ones, everything other than those 5. So when I'm working on this particular problem, the first thing that I'm going to look at when I'm looking at these 5 here is just to classify my cations and my anions as either being acidic or basic. So I'm going to kind of zoom in here a little bit. For my first molecule, I have KCN. K is my potassium is my cation, and this is a neutral cation, so I'm just going to put a little N on top of it. The cyanide, my anion, is Cn-. This is not one of the 5 neutral anion, so that means that this is a basic anion. When I have an ionic compound that is coming from a neutral cation and a basic anion, the neutral cation is basically canceled out, and the ionic compound as a whole is going to be basic. So I'm just going to tag this as this is going to be a basic solution. It's going to have a high pH. This is going to kind of help me a little bit with the ranking. Let's do the same thing down here. We have the sodium cation. That is one of our neutral cations. We have ClO-. Be careful, it's not ClO4. So that means that this is not neutral. We have a neutral cation with a basic anion. So that means that this one is also going to be a base. And our next ionic compound, our cation, is all of this right here. It's kind of a little bit tricky to identify it, but maybe you identify the bromide ion. That's a pretty common anion. And since this is our anion, that means everything else over here must be our cation. This is not an atom in group 1A or 2A. So that means that this is an acidic cation. And then our anion, bromide, this is one of the neutral anions. So this is an acidic compound. And then last but not least, we have sodium, which is neutral, and we have iodide, which is also neutral. So that makes this whole entire ionic compound is going to be neutral. And again, what I was doing there with all of these compounds is I was looking at the cation, determining if the cation was neutral or if the cation was acidic, and then I was looking at the anion and doing the same thing. Is the anion neutral or is the anion basic? So this has got me just kind of a good start on this, and since all I'm doing is ranking these by their pH, since I have something that's an acid, I know that this is going to be the one with the lowest pH because this is the only one that is an acid. It's the only acid that I have. And then moving up the pH scale, this is going to be neutral. So this is going to have a pH of 7. So this is going to be my number 2. some pH, it's going to be a pH of 7, which is going to be something higher than my acid. So all I really have to figure out are these two, both of these, because both of them are bases. These are both going to have a pH greater than 7. I just have to figure out which one has the higher pH. So this, I've just kind of simplified this problem quite a bit. Now, for me to determine between these two bases, which one is going to have the higher pH, I'm going to need to be using the Kb values for these bases. So we want to compare the Kb of my first base, which is cyanide, Cn-, to the Kb of the second base, which is ClO-. So the base cyanide versus ClO-. The data table up here does not give us the Kb for anything that we actually need, but notice over here it does give us the Ka of HCN, which is the conjugate acid of Cn-, and it also gives us the Ka of HClO, which is the conjugate of ClO-. So we can calculate these Kb's from Ka. Using the relationship Ka times Kb equals Kw, we know that the Kb is going to be Kw divided by Ka. Ooh, this problem is tedious. So for the cyanide, we are going to take the Kw, which is 1 times 10 to the minus 14, that's a constant, and we're going to divide it by the Ka of HCN, 4.9 times 10 to the minus 7. 4.9 times 10 to the minus, oh, I said 7, but I meant 10. 4.9 times 10 to the minus 10. So we get 1 times 10 to the minus 14 divided by 4.9 times 10 to the minus 10. We have a Ka value of 2 times 10 to the minus 5. So the Kb of cyanide is 2 times 10 to the minus 5. Now we need to do the exact same thing for ClO-. We need to calculate the Kb of ClO-. We're going to use this same equation, but this time we're going to be using the Ka of HClO. 3 times 10 to the minus 8. 1 divided by 10, or 1 times 10 to the minus 14 divided by 3 times 10 to the minus 8 gives me 3 times 10 to the minus 7. So the Kb of this is 3 times 10 to the minus 7. Now that we have these numbers, what are we going to do with them? The larger Ka or Kb value is corresponding to the most basic, the more basic of the two, the one that is a more stronger base, and that's going to correspond to the one that has the higher pH. So when we come back to our rankings here, because KCN has the larger Kb value, 10 to the minus 5 is larger than 10 to the minus 7, this is going to have the highest pH, and this one will be the next highest pH. Now, if you end up with one of these problems that's asking you to rank and you've got to decide between two acids, you're going to be comparing Kas, you're going to use basically the exact same thing. The thing that has the larger Ka value is going to be the one that is the most acidic. But because it's the most acidic, that means it's going to correspond to the lowest pH or the lower pH.